Hey guys, in this video we're going to be talking about solving systems of equations by elimination again, except this time they're going to be in the form of word problems. So let's take a look. Alright, first problem. You are selling tickets to this Friday's basketball game. Student tickets cost $1.50 and adult tickets cost $3.25. You sold 358 tickets and made a total of $752.25. Let X represent the number of student tickets sold and Y represent the number of adult tickets sold. All right, so the first thing we need to do is write a system of equations that represents this situation. Now, once again, I'm going to focus in on the totals here. I know that I sold 358 tickets, and I also know that I made a total of $752.25. So that means one equation is going to be all about the tickets, and the other equation is all about the amount of money earned. So let's start with the money. I know that every student ticket is $1.50 and X is number of student tickets. So that means that it's going to be 1.5X and then plus 325 for every adult. So 325Y, and I made a total of 752.25. So that's my first equation. My second equation comes from the total number of tickets. Now remember, I only have adult and student tickets. So if I take the number of student tickets and add it to the number of adult tickets, I'm going to get a total of 358 tickets. So that is my system that represents this situation. Now we're going to solve it using not substitution, but elimination. That's a typo. Okay. So I noticed that the coefficients of the bottom equation are both 1. So that equation is going to be the easiest one to manipulate to get it equal to the top one. Now, I already know that I can't just eliminate because the coefficients of the x's and of the y's are not same number opposite signs. But if I take this equation and I multiply it by 1.5, that will match the 1.5x on the top. But because I need them to be opposite signs, I'm going to actually multiply by a negative 1.5. So if I do that, I'm going to recopy the top equation because I haven't done anything to it. So that's 1.5x plus 3.25y equals 752.25. Okay? And then I'm going to multiply the bottom equation by negative 1.5. Negative 1.5 times x is negative 1.5x. Negative 1.5 times y is negative 1.5y. And then I'm going to get my calculator out and make sure I do this right. So negative 1.5 times 358 is negative 537. So now that I've done that, I can take these two equations and I can add them together. That will eliminate the x's because 1.5x plus negative 1.5x is 0. So now I have 3.25y plus negative 1.5y, which leaves me with 1.75y. Then I have 752.25 plus negative 537 to give me 215.25. And the last thing I'm going to do is divide both sides by 1.75 to figure out what y is equal to. And I get 123. Now remember, your solution to a system is an ordered pair. So now that I have y, I need to plug it back in and find x. And I'm going to use this bottom equation because that's the easiest one to work with. So now I have x plus my y, which is 123, equals 358. And the only thing I need to do is subtract the 123 on both sides to get x equals, let's see, 358 minus 123 is 235. So then my solution would be 235, 123. So if I were to interpret what this means, it would mean that you sold 235 student tickets and 123 adult tickets to the basketball game. Let's try another. All right, the cost of 8 avocados and 3 tomatoes is $8.39. 4 avocados and 12 tomatoes cost $11.44. Let X represent the number of avocados and Y represent the number of tomatoes. So once again, we're gonna write a system that represents the situation. Now this time we have two groups of the same thing, essentially. One group is buying a certain amount of avocados and tomatoes and has a total amount of money, and the second group also bought a certain amount of avocados and tomatoes and paid a certain amount of money. So my equations are gonna be very similar, except the coefficients and the total are going to be different. Okay, so X is the number of avocados. So the first group bought 8 avocados, so that would give me 8X. They also bought 3 tomatoes, so 3 times the cost of the tomatoes, and that's going to equal $8.39. So really what this should say is not the number of, but the cost of avocados and the cost of tomatoes. Okay. All right. Now the second group bought 4 avocados, so that's 4X, and they bought 12 tomatoes, so plus 12Y, and they spent $11.44. So that's the system that represents this situation. Now once again, we're not solving by substitution, we're doing elimination. Okay. All right, so let's do it. My X's are not same number, opposite signs, and neither are my Y's, but I do know that I can multiply 4 by 2 to get 8. So I'm going to multiply this bottom equation by 2, but I'm going to make it negative because the signs right now are the same and I need them to be different. I need them to be opposite. All right, so I'm going to rewrite the top equation. 8X plus 3Y equals 839. And then when I multiply, negative 2 times 4X is negative 8X. Negative 2 times 12Y is negative 24Y. And 1144 times negative 2 is going to give me negative 22.88. Okay, now I'm going to add the two equations together. 8X and negative 8X make 0. 3Y plus negative 24Y is negative 21Y. And 839 plus a negative 22.88 is negative 14.49. So what I'm going to do now is divide by negative 21 and figure out what my Y is. And I get 0.69. So now we have to ask ourselves, does this number make sense? Because this is probably one of the first questions we've come around that has a decimal as an answer, which is absolutely possible. So we know that Y represents the cost of a tomato, which in this day and age is probably not 69 cents anymore, but it is a possibility. So we're totally okay with this answer. But we need to figure out the cost of an avocado as well. So I'm going to take this 69 cents and plug it into one of the two equations. It doesn't matter which one you choose. Let's go ahead and do the top. So I have 8X plus 3 times my Y, which is 0.69, equals 839. All right, and then I'm going to do the multiplication. 3 times 0.69. So now I have 8X plus 2.07 is 8.39. Subtract the 207. Get 6.32. So now I have 8X equals 632. Divide both sides by 8 to get 0.79. So that means my solution is 0.79.69, which means the cost of an avocado is 79 cents and the cost of a tomato is 69 cents. All right, next one. All right, Robert is 12 years older than Helen. The sum of their ages in years is 178. Let X represent Robert's age and Y represent Helen's age. So we're going to do the same thing here. We are going to write a system of equations and then we're going to solve it using elimination. All right, so we know that Robert's 12 years older than Helen and their ages together is 178. The easier one to write this time is the sum of their ages is 178, because all that means is if I take Robert's age and I add it to Helen's age, I'm going to get 178. okay? It's that second equation that can be a little bit tricky. So this part of the sentence here where it says Robert is, this word is, you can think of that as being an equal sign. So Robert's age is X. So Robert is 12 years older than Helen. So if I take Helen's age and add 12 years to it, I get Robert because he is older. Okay. Now I know that this equation is set up better for substitution, but we're going to practice elimination. But the only way this works is if this bottom equation is written into standard form. So in order to do that, I need to move this y over to the other side. So I'm going to subtract y on both sides. So that's going to give me x minus y equals 12. All right, so let's put that together over here. So here's my top equation that did not change. It's x plus y equals 178. And then I'm going to take this bottom equation and put it right underneath. X minus y is 12. Now the nice thing about this is now if you look at your y's, they are same number, opposite signs. So I don't have to do any work. I can automatically go into adding my equations together, which will cancel out the y's. So I have x plus x, which is 2x, and I have 178 plus 12, which is going to be 190. Divide both sides by 2. And I get x is 95. So that means Robert is 95. So now I can go and I can figure out how old Helen is. I'm going to use this bottom equation here. Well, let's go ahead and use this one actually. It doesn't really matter. Actually, let's use the top now that I've gone all the way around. So I know that x is 95, so I'm going to plug 95 in for x. So 95 plus Helen's age, which is y, is 178. So if I subtract 95 on both sides, I will figure out how old Helen is. So 178 minus 95 is going to be 83. So that means my solution is 95, 83, meaning that Robert is 95 while Helen is 83. So this problem here is an example where you would get to choose whether you want to use substitution or elimination. If you want to use substitution, you would take the y plus 12 and substitute it in for x and proceed from there. If you want to do elimination, you have to do everything that we just did here. But you would have a choice. But that's it. That's how you solve word problems involving systems by using elimination.